So in the last video, we have discussed about dot product. So here we need to discuss what is vector product or cross product. So cross product or vector product is defined as product of magnitude of first vector and second vector, right, and sine of smallest angle between them. Okay, repeat, cross product or vector product of two vectors, maybe a vector and b vector, two vectors, vector a and vector b, is a magnitude of vector a into magnitude of vector b into sine of smallest angle between them. But since it is a vector product, as the name indicates, when you multiply two vectors as a cross, that is when you find the cross product, the resultant will also be a vector. So as per the definition which I have just given you, we are going to get only magnitude, right? Because magnitude of A, okay, will be some value, magnitude of B will be some value, right? Then sine of angle, if theta is 0, okay, it is 0. If theta is 90 degree, it is 1. So it's some value. So a new vector will be formed when you do A cross B, right? Maybe C vector, and that vector should have a direction, right? And that direction will be always normal to the plane containing these two vectors. That means when you cross product two vectors, okay, lying on same plane, you will get a new vector which will be perpendicular to the plane containing the vectors A and B. This you can see in the figure. I have A vector maybe in y direction, okay, and B vector on the lying in the same plane. Okay, you have to understand that the B vector is towards you, away from the screen, okay, towards you, and they are separated by angle theta. Then the resultant vector after the cross product will be something like C vector, which will be normal to the direction of plane containing A and B. So it is, you can see here, if this is a plane, okay, this is a plane, then the C vector is normal to that plane. Is that clear? So let us see how to express it mathematically, and let us see how to compute mathematically cross product of two vectors. Okay, first let us see general representation, then we will take an example and check how we get it. Is that okay? So we write as defined cross product of A cross B as magnitude of A, magnitude of B, sine of smallest angle between them, okay, as you can see in the diagram, theta, and the new vector formed will be normal to, okay, both the vectors. So we represent normal vector as A n cap. Okay, by the time you know that A cap is used for representing unit vector. So by A n cap, what I mean is I am representing the direction using that unit vector, okay, which is normal direction. So new vector formed will be in that direction. That's the meaning. So this entire part will give me the magnitude, and this will tell me the direction. Is that okay? And I hope this figure is also very clear. Okay, so to understand it better, remember that when we find the scalar product or dot product, your final answer was a single scalar value, right? You are going to get a scalar resultant, scalar product here, but you are going to get a new vector which is normal to the both the plane containing both A vector and B vector. Okay, now similar to the previous exercise of dot product, we have to take general expression for vector A, vector B, then we have to cross product them to get the expression. So this is my A vector, this is my B vector. So I have to find A cross B. So I have to multiply the first term, right? I have to cross the first term with the second term. So I have already written the equation here. So first ax cap term with bx cap, by cap, bz az cap, right? So I get ax bx because these two are magnitude. So I write them directly. Ax into bx means maybe 3 into 2, 6, doesn't matter. But these unit vectors you have to cross it. Okay, so ax cap cross x cap plus next I'll get ax this into second term, right? Second term. So ax by ax cap cross ay cap plus ax bz ax cap cross az cap. These are, you have to be very careful while writing. You should not change the order of this. Okay, so the first term is having ax cap. So write ax cap first everywhere. Ax cap first, then the second. There is a reason for that. Okay, if you shuffle the order, okay, you are going to get a wrong answer. We'll discuss why or how. Now the second term, okay, similarly the second term multiply with all the three terms, okay, you are going to get this, and third term multiply all other three terms of vector B, you are going to get this. Okay, now to solve this further, we should know how to evaluate ax cross x cap, right? X cap cross x cap or x cap cross ay cap, right? So deriving the same idea of dot product, let me try to find what is x cap cross x cap. What will be x cap cross x cap? So x cap cross x cap, from the definition of cross product, is nothing but magnitude of ax cap, magnitude of ax cap, right? Sine of smallest angle between them, that is sine theta, and the direction of new vector is an cap, right? But here ax and x, what is the angle between x vector and x vector? They are not separated, right? They are on same axis. So angle between them is 0. You cannot find angle between them. So angle is 0. So what is sine 0? So theta becomes 0. So what is sine 0? 0. So what does it tells you? Ax cap cross ax cap will be 0, and this is same as, this will be true for ay cap cross ay cap and az cross az as well. Is that very clear? Okay, this is just by taking it from the definition of cross product itself. Okay, so I get these terms to be 0. So in this particular equation, all the term with similar unit vector cross will be 0. I hope there is no confusion in this. Okay, 0. How I am getting it as 0? Then these terms will be 0. Okay. Now there are other terms. So 3 terms goes to 0. Now there are other terms remaining. Now you have to evaluate ax cap cross ay cap or x cap cross az cap, or for that matter ay cap cross az cap. Okay, all that. So we need to know how to evaluate it. Okay, for example, you see here you have ax cap cross az cap here, and you have az cap cross x cap here. Okay, we have to see whether both are same. Just now I told you that you should not shuffle the order. Okay, there is some meaning in that order also. So let us find how to evaluate this now. What is this ax cross az cap? Again, the idea is same. We have to use the definition of cross product and try to find what is, okay, x cap cross az cap or ax cap. So let me start with the second term itself. Ax cap cross ay cap. Okay, so my intention is to find ax cap cross ay cap. Agree? Ax y cap. So similarly I need to find the remaining also. Okay, so first let us try to find ax cap cross ay cap. How to find this? So by the definition of Ax cap cross Ay cap. We know that. I can write it as magnitude of Ax cap, magnitude of Ay cap, sine of smallest angle between them, okay, sine theta, okay, then the normal vector an cap. Agree? An cap. Okay. Is that very clear? So this is from the definition. So if I find the cross product of x cap cross Ay cap, I would end up with Ax cap magnitude, Ay cap magnitude, sine theta, An cap. Okay. Now what is magnitude of x cap? 1 unit vector, right? Then Ay cap is also 1, right? Unit vector. Now sine theta. What will be theta? The previous explanation of dot product, we have seen that the unit vectors are lying in 3 different planes and they are separated by an angle 90 degree. Right? If you have any doubt, you please refer the previous video. We have already explained x cap, Ay cap and Az cap are separated by an angle of 90 degree. Right? So this becomes sine 90. Okay, this becomes sine 90. Angle between Ax and Ay cap is sine 90 degree. Sine 90 degree. Agree? Sine 90 degree. And An cap. What is An cap now? An cap is normal unit vector to both Ax and Ay. Agree? An cap is normal vector, right? Because we have seen, see here, see this is An cap. In this figure, the C vector. I have A here, I have B here, and this will be, the normal to this will be C vector, right? So An cap is normal to this. So when you have x, so this is Ax cap direction, agree? This is Ax cap direction, this is Ay cap direction. So this will be normal direction to both. So xy plane, what is normal to xy plane? So you should be able to imagine, right? This is xy plane. Can you imagine this? This is xy plane. Now what is normal to this? Normal to this is z axis, in the sense z plane, right? So this is Az cap, agree? Because that is in the, that unit vector is in the direction of z axis. So which is this An cap? The An cap is nothing but Az cap, right? Why? Because I have Ax cap cross Ay cap. So I should have a normal vector to both Ax and Ay. So what is that now? Az cap. So this becomes cross Az cap. Agree? So 1 into 1, sine theta is 90 degree. So sine 90 into Az. What is sine 90 degree? 1, right? So what I end up with? 1 into 1 into 1 into Az cap. So I end up with Az cap. So what does it say? Ax cap cross Ay cap is nothing but Az cap. Az cap. Is that very clear? Similarly, okay, now you should be able to define remaining two. Which are remaining two? I have in my equation Ay cap cross Az cap, and in my equation I also have Az cap cross X cap, right? So I should be able to tell these two also now. Okay. Now, if few students will be having some confusion, as I told you, if I change the direction, so for Ax cap cross Ay cap, I got Az cap. Sir, then what is Ay cap cross Ax cap? Okay. So to understand that, see here, we have to consider this as a right hand coordinate system. What? A right hand coordinate system. That is, this is a 3-dimensional XYZ coordinate system or Cartesian coordinate system, it is commonly known as. And we are considering a right hand coordinate system. So in a right hand coordinate system, anti-clockwise direction is taken as positive. So this direction, x to y. This direction, y to z. This direction, z to x. Is that very clear? I'll repeat. It's a right-handed coordinate system. So in a right-handed coordinate system, anti-clockwise direction of axis is considered as positive. So x to y, okay, when you are tracing, then y to z when you are tracing, and z to x when you are tracing is considered as positive. So this means that the other direction should be negative. So now it's very clear. So ax cap cross ay cap. So I am tracing it in the positive direction. So that's why az cap is positive. So if I trace it in the opposite direction, that is ay cap cross az cap. Sorry, ay cap cross x cap. Then what I get? If I trace it in this direction. If I trace it in this direction, then it is negative. Agree? That will be negative. So ay cap cross x cap will be minus az cap. Interesting. Okay, now tell me what will be ay cap cross az cap. Ay cap cross az cap will be, so I am tracing it, this is y axis, so y to z. Ay cross az will be normal to that. So what is normal to that? X. So this will be ax cap. Agree? Now az cross ax. So az is here. Okay, this is az. This cross ax, this. So it is in positive direction. I am tracing it in positive direction. So this is normal vector to this plane. So normal vector to this plane is ay cap. So the third one. Okay, it is easily az cap cross x. So similarly, okay, az cap cross ay cap will be minus ax cap, and ax cap cross az cap will be minus ay cap. Is that okay? Yeah. Now we need to substitute these conditions into this previous equation. Okay, I need to substitute all these conditions into this equation. Okay, so what is ax cap cross ay cap? X, yeah, it is az cap, positive az cap. So you please substitute here. Okay, you need to substitute here az cap. Okay, similarly in each place you please substitute this. Okay, so if you substitute, you will end up with equations like a cross b now reduces to a cross b now reduces to ax by az cap. So I am substituting, okay, whatever we have discussed just now. Ax bz, okay, I have ax cap cross az cap. So this will be minus ay cap, right? Minus ay cap plus ay bx minus az cap plus ay bz ax cap plus az bx, right, bx ay cap plus az by minus ax cap. I hope this is very clear how you are getting this, right? Okay, now what we need to do is bring all ax cap terms together, bring all ay cap terms together, bring all az cap together. That's it. Okay, so here I have my x cap term, I have another x cap term here. So you try to bring them together. So what I get? Ay bz, agree? Ay bz minus, because there is minus sign here, so that minus sign I am taking it out. So az by, this entire thing is my ax cap. Nice. Okay, so plus similarly for x cap, sorry, for ay cap, I have ay cap term here, I have another ay cap term here. Okay, so positive term I'll write first. So az bx minus ax bz, this is ay cap. Okay, plus now remaining two terms, that is set terms. So positive term first, ax by minus ay bx az cap is common. This is clear? So this is my expression for A cross B. Okay, this is expression for A cross B. Okay, this is Y. Okay, Y expression for A cross B. Now look at this equation. Can I write it in a better form? I have AY BZ minus AZ BY. Okay, and X cap is common, and this minus this and AY cap is common. This minus this and AZ cap is common. Okay, so what comes to my mind is I can write it in a determinant form. Okay, I can write it in determinant form. See, let us see how it is. Okay, so what if I write that equation as A cross B? Okay, that particular equation. What if I write it as a determinant of AX cap, AY cap, AZ cap? Okay, AX, AY, AZ, BX, BY, BZ. I can write this, right? I can write it in this form. So you can see that for the first determinant is AY, right? AY BZ minus AZ BY into X cap. That's what I need, right? So I can easily write it. You can check the remaining terms also. So I can easily write it in this form. So this is how I find the cross product. So to rewind, when we find the dot product A cross B, I get a scalar as the resultant, right? So I get a single value. So A cross B will be, A dot B will be magnitude of A, magnitude of B, cosine of smallest angle between them. When you calculate, we'll get a single value. But when we try to do cross product of two vectors, cross product says that a new vector will be created, right? Because it is vector product. You have to get a vector as the product. So you'll get a new vector, and that vector will be normal to the surface or plane containing your two operand vectors, B vector and A vector. Okay, and how to calculate the value of that C vector? That is this equation. Okay, so your new vector will be formed, C vector, and C vector is calculated like this. Because you will know magnitude of this, magnitude of this, magnitude of this, all these values will be given to you. You can directly substitute here and find what is your new C vector. So hope theoretical concept of cross product is clear.